Hi, everybody. Let's talk a little bit about land navigation. While what I'm about to cover here is a very complete overview, it still is not a substitute for real hands-on training. So, always seek safe hands-on land navigation training from a capable instructor. I'm also going to be going fast, so you got to keep up. You can review portions of the video later and pause when necessary. Okay, let's jump right on in. This here is my bug out setup, and while I'm not a very big fan of bugging out, I do like to keep a bag handy that has 1, extended capabilities and 2, transportable capabilities. And part of extended capabilities for me is having the ability to competently navigate on land, period. Now that's just the way I roll, and your approach may certainly vary. So let's very quickly go over the key components of the map case here. First, the case itself is made by Seattle Sports. Over here is a small solar calculator, which is totally optional. I myself use it to double check my mathematic calculations that I usually do by hand. Here's a protractor, a pencil with lead inserts, a good quality eraser here, something that won't smudge your map, a straight edge, and finally your actual compass. Now this is your basic land navigation setup. Nothing fancy, just straightforward. Now before we proceed any further, we must go over geographic coordinate systems. It's the baseline for everything else that's going to follow in this series. Now, by far, the most common geographic coordinate system is Universal Transverse Mercator, or abbreviated UTM, and the 2 most common scales in this coordinate system are 1 to 24,000 and 1 to 25,000, and we'll talk about representative scale in more depth in part 2. Now, UTM is responsible for giving us all those helpful little grid lines that live on our maps. Now, coordinate systems can be complex, so here's just a very brief sketch. UTM essentially divides the Earth up into 60 longitudinal zones, and with a few exceptions, each zone is 6 degrees wide. Each zone is also assigned a number 1 through 60, as you see here. And over here is a better look. Added to this are 8-degree wide latitudinal bands that intersect the 60 zones, and in so doing forms a worldwide grid of sorts. Here's another look at that. And you live in Miami, then you're in zone 17R. The longitudinal zone number is noted first, followed by the latitudinal band letter. Now, because of the curvature of the Earth, the transverse Mercator projects lines or graticules that are naturally curved. But for purposes of simplicity, scientists and surveyors have adopted a modified grid plane like this one here. And it makes plotting for us normal folks a lot easier. In fact, it's a lot like geometry. You're essentially working a grid. You plot on the x-axis from left to right, and then upward on the y-axis from bottom to top. The intersection of those 2 lines marks your position. Okay, let's take this one step further. When we look at any map, such as this one, there are a lot of funny numbers on the top and side margins, right here and right here. First of all, they're in a weird format. Some numbers are smaller and others are bigger. So what do these numbers mean? Good question. To start with, do not be confused about the multiple size numbers. It's really just one number. For example, this one over here really just stands for 4,319 kilometers. That's all. How about this one over here? It really just stands for 744 kilometers. Simple. Now, recall that I said that each UTM zone was made up of a northerly band that was 6 degrees wide. Well, when we measure northing in the northern hemisphere, we're actually measuring the distance from the equator in kilometers upwards along the zone we're in. That's it. So, for instance, in the previous example, this grid line was labeled 4,319 kilometers, correct? All this means is that this specific grid line here is 4,319 kilometers from the equator of the Earth to this grid line. Simple. If you're in the southern hemisphere, your UTM northing measures the distance from the South Pole to your grid line location. Okay, now to repeat, if you're in the northern hemisphere, your UTM northing coordinate measures the distance from the equator to your exact grid line location. Pretty straightforward. Unfortunately, easting is not that straightforward. Whereas with northing we were measuring from the equator northward to our grid location, with easting we are not measuring from something like the international date line eastward. No, we are instead measuring from the center of the UTM zone that we're actually in. I know that sounds weird, so let me explain it again. Here's the deal. Each UTM zone is divided in two, and each dividing line is called a central meridian. Each zone has a central meridian. So each central meridian for each UTM zone is assigned an arbitrary measurement number of 500 kilometers. Okay, let's try to clarify this by using our earlier example. Remember previously that we had a vertical grid line of 744 kilometers, correct? That simply means that this grid line is exactly 244 kilometers to the east of the central meridian you see here, which would be around here. Now, if it were a number lower than 500 kilometers, it would be located to the west of the central meridian. For example, say this number was 480 kilometers. Just pretend for a moment. A vertical grid line of 480 kilometers simply would mean that this grid line is exactly 20 kilometers to the west of the central meridian here, which would be around here. Okay, that's it for part one. I know I covered a lot of new material here, but this is material that every Marine, Special Forces trooper, Navy SEAL, and especially infantrymen have not only mastered, but used daily in the field. Stay tuned for LandNav Part 2, where I'll be covering in depth the following topics: the anatomy of UTM grid coordinate formats, representative fraction and scale, and finally map types for land navigation. This is Analytical Survival saying, stay safe, my brothers and sisters.